Okay. Now we will discuss more analytic structure in space. Namely, we will start with planes in space, in R3. Of course, in R2, you cannot have this concept because R2 itself is a single plane, so there are no other planes in it. But there are straight lines. Now we are increasing the dimension a little bit, so we will have both straight lines and planes in space. Well, let us look at this geometrically. Suppose we have a plane. Okay, so this denotes the plane. So pi is, by the way, is a letter in the Greek alphabet, and it does not always mean the constant. So this is now the name of the plane, pi. Okay, and suppose we have a point on it. Okay, and suppose we have a vector which is perpendicular to the plane. Now here, completely think geometrically. The idea is to determine, okay, what the equation of the plane could be. Now, suppose these are given. Then, if P is on the plane pi, we have then the following structure. We have a P0, we have a point P on the plane, and we have a normal vector, n, perpendicular to the plane. Now, obviously, from the origin, if you look at P0 or P, they are not perpendicular to it. But if you look at the vector from P0 to P, okay, it's on the plane, parallel to the plane, so it will be perpendicular to n. Then, okay, P0P sorry, is perpendicular to n. Thus, okay, P0P dot n is 0. Now, conversely, if P is on pi, if we have a point on pi, then, okay, just again, looking at the picture so far, if P is outside of the plane, if it's above or below the plane, P0P, okay, clearly would not be perpendicular to n. Because we have a plane and we have a normal to it, a vertical vector. And if, okay, it will be perpendicular only to vectors, lines, or line segments on the plane. But if P is not on pi, P0P will not be parallel to the plane, so it will not be perpendicular to it. In other words, okay, if P is, right, I should say, if P is such that P0P dot n is 0, then, okay, P is necessarily on pi. So together, they say that P is on the plane if and only if this dot product is 0. Well, this is another expression of saying that this is the equation of the plane. So P0P dot n equal to 0 is the equation of the plane pi. Now let us look at this equation more carefully and give some values to P and P0. So if, okay, P is x, y, z, and P0 is x0, y0, z0, and n is ABC, then okay, the equation becomes okay, P0, P of course is P minus P0, so it is x minus x0, y minus y0, z minus z0, dot product with n, and that's equal to 0. So then, okay, we can of course write this in a shorter form, namely ax plus by plus cz equal to a number d. So this is another form of the plane equation. Okay. Now before we go to our examples, let us observe a few things about the plane equation. Firstly, a plane is determined by a point P0 on it and a vector called a normal vector which is perpendicular to it. So you need a perpendicular vector and a point to determine a plane. Secondly, okay, the normal vector we have, okay, has no importance of direction or magnitude. Okay? The normal vector n can be or can have any direction. Okay? But of course, okay, n must be perpendicular to the plane. Okay? And okay, any magnitude. These are not important at all. Okay? So there's no single n, but infinitely many of them. Taking minus n is okay. Taking 2 times n is okay. Okay. Thirdly, okay, of course, 3 points, 3 non-collinear. That means not on one line. Okay, points determine a plane. Okay, this is geometrically clear, but we will see it in our examples in more detail.